Michael, thank you very much indeed for making time to talk with me. It's fascinating. You've just presented to me, and it's going to be on the YouTube channel alongside this interview. You've just presented to me the case for improving the management of aircraft. But before we come back to that, can you just tell us something about yourself, Michael?
Yes, I've been basically a commercial pilot and military pilot my whole career. I graduated with a aeronautical engineering and business degree back in the early 70s. I got involved in flying in the Air Force and then went into airline industry, working on different systems. And back in the 1980s, when I started all this, I wrote my first article about flow management for Pro Pilot magazine here in the United States. But at that time, I really thought most of delays, congestion, and the excess CO2 and waste in the system was a function of air traffic control, like most people did at the time. So in the late 80s, early 90s, as I was working on other projects within United Airlines, along with flying, I also looked and said, well, we really need to determine what the core issue is with all this delay, congestion, and waste. We need to know what that cost, and then we need to know what we want the system to be, right? Those are kind of three pillars from an engineering perspective that I look at. You really got to understand what's going on. So everybody agreed, but nobody did anything. So finally, after 3 years of pushing and shoving, a gentleman, United, a financial analyst, did that one slide in the presentation that talks about the inefficiency of the system. At the time, he thought that was air traffic control. I've come to realize otherwise. So in the mid-80s, mid-90s, when nobody really did anything, I went with another gentleman, Michael Baiada, and we did a paper called Free Flight. It basically said, how do airlines want to operate, and what does it cost, and what are the underlying problems? Well, that got a big introduction. People started paying attention. FAA spent $1 billion on the Free Flight Select Committee, which I envisioned and I proposed as 8 to 10 people, got to 200 people, and it never really went anywhere, even though FAA probably spent $1 billion or whatever. It was a lot of money. And so in the late 1990s, I said, well, if ATC is not going to do this, what can airlines do on their own without anybody else? And the deeper I got into that, the deeper I realized that 80% of this problem, 85 to 90% of this problem is internal to the airlines, because it's not a managed system day of production process. As I said, the airline is a simple production process that takes in raw materials, the front end, people, bag, fuel, cargo, does lots of processes and spits them out the other end. Well, if all those processes are managed independently without system regards, it creates a huge amount of variance. And over the years, my partner and I, Lonnie Boland, we created a system and looked, well, the core of that problem is the movement of the airplane, right? Yeah, you can manage gates better, you can manage maintenance better, but if that, as the one chart in the slide presentation showed, the amount of variance in terms of on-time delivery, every day it's early, late, you don't know what the system and the gate and the maintenance required. So the movement of the airplane is the key element that why people buy tickets. It's their primary motivator. It's the highest cost element for the airline. And it's the biggest defect generator, of passenger not where they were promised when they were promised. So that's what we attacked. And that's what business-based demand management really is. It's taking the flow of aircraft from a system perspective and putting that into action in real time, day of, 2, 3, 4 hours prior to landing.
Michael, one of the things, thanks for that. One of the things you didn't mention in your presentation, which given the number of times I've been stacked coming into Heathrow or Gatwick, surprised me a bit. You didn't talk about stacking, but presumably that's a consequence of the same thing. But all that's doing is just increasing the amount of wasted fuel.
Yes, and stacking is, in the presentation, I talked about the length of final. As I said, final approach is how far from the airport you go away from the airport to line up with the runway and come back and land. Typically, from a pilot perspective, you need maybe 6 to 8 miles at most, just to get everything lined up. Anything more than that is waste and inefficiency. So stacking replaces that 30 to 40 mile final. And in Heathrow is very good example, because what happens is it's got the curfew. So you can't land before 6 o'clock. And so people, they just show up, they overload the airport. ATC has to put them somewhere. It's what manufacturing call work in process inventory, right? What am I going to do with these 20 airplanes that all want to land at 6 o'clock in the morning? Well, you stack them. In other airports, like in Chicago, you can stack them, but most times you run them out over Lake Michigan, as I said. And again, it just burns huge amounts of fuel. The interesting part is, one time I flew over the North Pole, closer to the North Pole, into London. So I came in from a whole different direction than I usually did. Well, I was east of the stacking the points north and south at the airport. So they brought me straight in. Well, I came straight in, and I was 9 miles behind another 747. I was in a 747 as well. Separation between two 747s is 5 miles. I was 9 miles behind another one. There was nobody taking off in front of me. So end result, we wasted almost the whole landing slot, and that happens over and over and over again. Maybe not at 4 miles, but it's an extra mile, an extra half mile. So after 5 or 6 aircraft, you've wasted a whole landing slot because you overloaded the airport, and the air traffic controllers are just working harder than they should.
So the whole problem here is really a lack of system engineering and proper management of the sort that would horrify anybody who runs a production line or any other kind of production process. They'd be fired, wouldn't they?
Absolutely, and that's exactly what the problem is that we have what I call a wing and a prayer airline operational day of approach. We send a few $1 billion worth of aircraft out on the wing and pray that it comes out okay. It rarely does. Now, the outcome's random, so it could, but it rarely does. So what happens at Heathrow? You get stacking. It's interesting. I had to get to my arrival time was 6:08 or 6:10 at the gate, which means I had to land pretty much right at 6 o'clock to get to my gate on time. So I hadn't flown much to Heathrow, so I talked to the other pilot, and I said, okay, when do people start to stack? And they said, well, probably 15 minutes prior. So what I did, I sped up a little to get there at about 18 minutes to the stack before early, and I was number one in the stack. So I landed at exactly 6 o'clock, taxi to my gate, and my dispatch called me and said, how did you do that? And I said, do what? Well, you're the only one that's been on time at Heathrow, for the last 3 months. And I said, well, I planned it that way. And he goes, what do you mean you planned it that way? Well, I knew what the stack was going to be, I guessed, right? But we have so much better data than I have access to in the cockpit.
Sure.
Right? And leaving it to the pilot or individual dispatcher to independently make decisions. For example, I may speed up because I'm late to end up at the tail end of 20 aircraft that ATC puts me back where I started. All I did is waste the fuel, right? Yeah. Or I may slow down to save fuel right into the front end of a queue of 30 aircraft, and that adds an extra minute or two to every one of those aircraft, and the fuel it burns. So this whole concept of queuing, variance, logistics that every other industry understands from a system perspective, supply chain, is just not put into practice in the movement of the airplane day of.
Michael, what I think I'm hearing is that there's a kind of shifting of responsibility, that the people who are expected to try and sort this out are either the individual pilots who know only about their own aircraft, really, they don't know what else is happening in the system, or it's air traffic control, by which time it's probably too late because they're already too close to Heathrow to actually affect the takeoff and the routing.
Yeah, absolutely correct, right? As an individual pilot, I can make decisions, and I can make good decisions about my aircraft. I could find out, is my gate open, is how much fuel I'm going to burn, et cetera, et cetera. But I don't know the other 10 aircraft around me that also are trying to make independent decisions. So the outcome is highly random and very inefficient. The same for air traffic control is that they deal with the problem in the last 200 miles. So they sorted out 200 miles prior, maybe 300
That's too
miles.
late, isn't it?
So it's too late, absolutely too late. Now, air traffic control is spending lots and lots of money, billions of dollars, to try and reach out beyond the 200-mile limit. The only problem with that, and they can do that, and it will be slightly more efficient, but the problem is they don't know the business needs of the individual aircraft. In other words, if you're early and I'm late, but you're in front of me, ATC is going to leave you in front of me and make me later, right? And additionally, they don't know if an airplane can speed up. And that's a real key element here in that actually reducing fuel. Now, people look at that and they go, well, if you speed the airplane up, you're actually burning more fuel. And I said, yep, for that individual aircraft, that's correct, typically. Well, but think of it as you and I are the first two aircraft in a queue of 30 airplanes. If they speed us up, which burns more fuel in our our two aircraft, the end result, though, is that takes 2 minutes earlier for us, but it also 2 minutes earlier for everybody behind us. So in other words, you took 60 minutes of flying time out of that arrival queue, and 60 minutes of CO2 and 60 minutes of noise, low altitude maneuvering. It's all gone, right? It's not magic. It really is simple logistics that, as you said, industry after industry for the last 40 years has applied. We just look at air traffic control and aviation and it's all magic. No, it's just simple logistics.
Michael, we're going to leave it there. Thank you very much for the interview. What we're going to do is come back to this and run a panel looking at how we get people to take responsibility to actually implement the kind of thinking that you're talking about. And we'll construct a panel, bring people together and discuss what makes it so difficult to do what seems to me to be the blindingly obvious. But thank you very much indeed, Michael, for that. You've stimulated a whole other area of work for us and we'll certainly take it up. So Michael, thank you very much indeed.
Thank you, Harold.